Remove this mouse directly. So I'm giving you the directions related to just simply making the sample in Abaqus. How? If I want to model a table, then I have to make it different parts first. I will give the shape of table legs, the drawers, then the upper blade, then join it. Just like garment. Join it by using nails. And the table will be ready. Same work will be here. So first I will decide what I want to model here and what is the geometry. I want to model the first sample P01, and you can see here is nothing else. There is only one part having diameter of 200 and height of 400. These are the modules. They are called modules. The first module is to create the part, different parts. If you want to model a room, complete room, you will model its different parts like walls, like columns, beams, slabs, foundation. Then you will tie them, or a room will be ready. Understand? A room, it is not like a process that start from this corner and just make it. No. You have different parts separately. First module to create parts. The third module is to assemble them, join them. First is to create different parts of a body. Second may be to create the properties. If you are making a table, then of course you have to define the properties of wood. The material will be wood, material property will be wood. Properties mean material properties. If you are making a column reinforced concrete, then you have to give the properties of concrete. Yes. If you are making the composite column next in any one from these sections, you have to also produce these parts, FRP tube and circular steel tube and all these, okay, and give their properties. If you are defining circular steel tube here, it will be fabricated, it will be developed. Okay, what are the properties of this tube? What will be the strength of this tube? All these properties will be given from this tube. When you are talking about steel tube, it is Q345. The yield strength, the elastic modulus, the section modulus, all the properties are hiding behind this Q345. So the second will be to define the property. First will be to develop the parts, different parts. Define the property for all parts. One part may be made of steel, the second part may be made of FRP tube, third part may be made of concrete. So all the properties for different materials will be defined in second module, and third module, that is assembly. You have to join all the properties, all the parts. Join the parts and make the shape you need. The third one will be joining process, and the next one will be step. When you apply the load on the fabricated model, and it will increase in the stepwise. Load will be increased in stepwise. If a column is bearing 1000 kilonewton, if the capacity of a column is 1000, it does not mean that it will bear 1000 in 1 second. It will gradually increase the load. Increasing, it's over 1000 crush. It will not be a simultaneous load than 1000 blast. No, that is impact load, something else. But in our case, in all the tests, they are static loading, static monotonic axial loading, increasing in one dimension only, not cycling, increasing in one dimension only. Very simple case is yours. Yes. Not cycling, not impact, not simultaneous. They are very tough. But your case is very simple, just increase the load in one direction. This increasing the load in with respect to time is called step. You will define the load and define its step also in 1 second how much load will be increased. If the increasing rate is the step is 1 kilonewton per second, then after 1 minute, how much load would be applied to the body? 60 kilonewton. Good, because the rate is 1 kilonewton per second. In 1 minute, there will be 60 kilonewton per second compressed. After step, there is interaction. Oh, when a carpenter joins all these legs and draws with the blade to make a table, then there is some connection between them. Just like nails and just like these shapes for opening it here, here's the connection. So that was one blade, it has been connected this blade with using this connection. This is called constraint. Or maybe nails, the nails available which are hiding. So nails are also interaction, interior connection. When you are joining the parts, what is their interior connection? Define it. There are different types of connection. You will model it and learn it. Load. Just apply the load. At which location you should apply the load? That is loading condition. You will select the location impact the load. Apply the load there. In your case, column, of course, you will apply the load on the top side of the column. Bottom side will be hinged, maybe fixed, maybe all the boundary conditions. All the boundary condition will be defined here. Boundary condition involves support conditions and loading conditions. All will be defined here. Now meshing. Have you studied structural engineering subject? Not studied. They will be studied next semester.
Structural engineering
Subject.
exact subject matter, but we are studying like
But we-
costs and
No, they are not.
structure.
They are relevant to structures, but structural engineering is a subject that will come hopefully in your last semester. So meshing. Oh, I have studied the stiffness method. Anywhere.
Stiffness of the map.
Oh, stiffness method for analysis of structures. Stiffness method. So in stiffness method, the working is the same. In stiffness method, we have to, if we have to analyze a beam, then we cut it into pieces. Not with the help of knife. That's just assumption. Cut in pieces and work node to node. Work from one element to other one to other. There are different types of loads. There are different types of elements. Detailed process. That is called meshing. Cut down your piece. Cut down your structure into smaller pieces, and then analyze them. That is called stiffness method. And meshing is the process of cutting down pieces. The next is optimization, means check whether there is an error or not. Is there anything missing? Yes. Just a cross check. Job. This job means just assign the job and run it. A simple process, one step process. Visualization means see the outputs. Check the outputs. What are the outputs? How this graphical representation of the model after the application of load, deformed shapes, and sketching also belong to graphs and results. So the first step is parts. I click on this. So I'm working on the plot. Yeah, when you click on different, you can see here, when you click on different modules, different icons appear. Your work mostly belong to this module and this icon. So I'm picking up the first case, P01. Just click on the create part, the first one. Just create the part. Click here, name of the part that will be concrete. I'm just writing concrete, simple.
You can write with PO1.
That is sample name. No, you cannot write it because in the next samples, you also create the part of concrete. Here is only concrete part. Here is only concrete part, other 0, 0, 0. So we are just only creating the concrete.
Yes,
Concrete shape. In the in the 7th, 8th sample, we will also create concrete plus steel tube, hollow steel tube plus